welcome to Badger Talks Live, which brings exciting happenings, resources, and talent from your UW flagship campus to the people of Wisconsin and beyond. I'm Jenna Green, and I'm from Delafield, Wisconsin. I'm a second-year PhD student at the Nelson Institute for Environmental Studies, where I study the links between policy, technology, and climate change. Before starting my PhD studies, I earned my Master's of Public Affairs from the Follette School of Public Affairs. I'm pleased today to introduce Greg Nemet, who will speak about the forthcoming State of Carbon Dioxide Removal Report, which is intended to regularly inform researchers, policymakers, and practitioners on the state of progress by systematically collecting and analyzing the vast amount of data and developments in many parts of the world. The main conclusion of this report is that if we are to meet the temperature goals of the Paris Agreement, scaling up novel CDR, expanding land-based CDR, and the rapid reduction of emissions are urgent priorities. Greg Nemet is the Vilas Distinguished Achievement Professor at the University of Wisconsin-Madison in the Follette School of Public Affairs. He currently serves as the Interim Director of the school. He teaches courses in policy analysis, energy systems, and international environmental policy. Greg's research focuses on understanding the process of technological change and the ways in which public policy can affect it. He received his doctorate in energy and resources from the University of California, Berkeley. His AB is in geography and economics from Dartmouth College. He received an Andrew Carnegie Fellowship in 2017 and used it to write a book on how solar PV provides lessons for the development of other low-carbon technology. The book is called How Solar Energy Became Cheap, a Model for Low-Carbon Innovation. He was awarded the inaugural World Citizen Prize in Environmental Performance by APPAM in 2019. Please welcome Greg Nemet.
Yeah, I'll talk today briefly about carbon dioxide removal from three perspectives. So first, as a director of the policy school, the Follette School of Public Affairs. Second, as a lead author for the UN Intergovernmental Panel on Climate Change. And third, as a founder and executive team member of the State of Carbon Dioxide Removal report that Jenna mentioned, and which is forthcoming in early June. So I'll talk about that. But the three main takeaways that I would leave for you about carbon dioxide removal is that first, as Jenna said already, meeting the Paris Agreement's long-term temperature goal will require rapid emissions reductions and scale up of carbon dioxide removal in the near term. So carbon dioxide removal does not replace emissions reductions, it's in addition to it. And second, how much? We think it's on the order of 15% of addressing climate change will have to come from carbon dioxide removal. The rest of it, 85%, will have to come from emissions reductions. And third, a small amount of carbon dioxide removal is already occurring. And the real challenge is scaling up some of what we're already doing and scaling up some of the novel processes to planetary scale so that they can be climate relevant. So let me just give you a few takeaways from my UN IPCC work and from some of the results from the state of carbon dioxide removal. So first, this is about the need for carbon removal. And this was in the summary for policymakers, which we negotiated about 2 years ago in the UN. And it's negotiated in that all member countries of the United Nations have to agree on this text. And this is one of the agreed sentences, that carbon dioxide removal is unavoidable if net zero CO2 or greenhouse gas emissions are to be achieved. So that's making the case that we need carbon dioxide removal. Second, and this is also from the UN, is looking at emissions reductions from where we are today, which is on the order of 50 billion tons of emissions of CO2 emissions we're putting into the atmosphere every year, and that those need to get close to zero by mid-century. And it's close to zero because the rest of it we clean up with carbon removal. And you can see that thin band of carbon removal, some of which is already occurring, and some of which will be grown in the future. And this is another result from the last year from the United Nations Environment Program that I and some of the others worked on, about talking about how much carbon dioxide removal we'll need. And this is where that 15% comes. And about a little less than half of it is what we sometimes call conventional or land-based carbon dioxide removal. And a little more than half of it is for novel carbon dioxide removal. But again, it's 15%, so 85%, the overwhelming majority of addressing climate change has to come from reducing emissions. So here, now I'll talk about the state of carbon dioxide removal. This was really some UN IPCC colleagues and I who thought that we needed to talk more about carbon dioxide removal after the IPCC report in 2022 said that we were going to need 15% or so of carbon dioxide removal. So what we wanted to do is get a sense of where we are today. And the motivation there, again, is that 15 years ago, 20 years ago, renewable energy was playing a tiny role. And there was a group of people that put together a report on renewable energy that eventually became the International Renewable Energy Agency. And now we have wind and solar producing more than 15% of global electricity and growing really quickly. And so that's kind of the model for what we're doing with the state of carbon dioxide removal. So here are the findings from the first edition from last year. So currently, we're removing about 2 billion tons of CO2 per year. Almost all of that is from what we call conventional CDR on land, so that's forestry. Tiny amount, 0.1%, comes from novel CDR. That's from things like biochar and direct air capture. The second point is that a large gap exists between carbon dioxide removal that's proposed by countries and what we would need to meet climate change goal. That third, reducing emissions can help lower that requirement. And that fourth, encouragingly, we do track these interim indicators of innovation and public awareness, and we do see that growing very quickly, including investment. And that's a new addition to the second edition of State of Carbon Dioxide Removal that we'll release in about a month. Okay, so just a little bit about the overall physical aspects of the problem. Basically, CO2 and carbon can be in one of 5 places: in the air, on land, in products, in the ocean, or in rocks, or the lithosphere. And what we're trying to do here is take some of the CO2 that's in the atmosphere and put it into one of these other 4 areas. So that's what carbon dioxide removal is all about. It's a challenge, and it needs to be done on a really large scale, but in the simplest way, that's what we're trying to do. More definitionally, when we say carbon dioxide removal, we're talking about methods that capture CO2 from the atmosphere. So we're not talking about avoiding putting CO2 into the atmosphere. It's taking stuff that's already in the atmosphere, durably store it. So that means not store it for one season, but store it over centuries to millennia. And that has to be an additional to the natural processes that are already happening. So those are our 3 principles for what we count and what we don't count as carbon dioxide removal, with some graphics to describe them. Many methods for removing CO2 from the atmosphere. One thing we found helpful is to make a distinction between approaches that we've been doing for a long time and we're doing at very large scale. That's on the left, that's conventional CDR on land, and ones that are new that we're only doing a tiny amount of. And that's the part on the right, and that's the 0.1% of the total carbon removal. But if we think about what we're already doing, it's things like forestry and restoring forests and managing forests to absorb more CO2. We could also capture CO2 through photosynthesis and have it stored as carbon in soil. And there's other methods as well. On the novel CDR side, we can think about biochar, where we take biological material in crops and pyrolyze it and turn it into a stable form of carbon that would stay for a long time and put it in soils. Or direct air capture, where we used chemical processes, sort of like what we use on submarines to get the CO2 out of the air. Could we do that on a really large scale? So lots happening on conventional, lots of effort on novel, but still small. Here's some work from IPCC about talking about the diversity approaches. All of them have trade-offs, all of them have risks, all of them have large potential. And one of the most important distinctions that we find is the durability of the storage. So if we put CO2 and mineralize it and turn it into a rock and keep it underground, that's stable and can stay underground for millennia. Some of the least stable would be putting it in crops or trees or in soils where a change of activity or a change of policy could quickly release it into the atmosphere. So one of the challenges is how to manage these different timescales of how long the carbon that we're taking out of the atmosphere will stay out of the atmosphere. Okay, and then one of the constructs we found has been really helpful was to talk about this gap. And it's a gap between how much we're doing and how much we need to do. And again, if we look at where we are today, we're doing about 2 billion tons of removal, mostly from forests, and about 0.1% is from these other areas, which is bioenergy with carbon capture, biochar, and a few projects on other novel CDR like direct air capture facilities. So almost all of what we're doing today is on forestry, and the other stuff is small but needs to grow. So that's where we're starting from, about 2 gigatons. If we look at what countries have pledged for 2030 in their nationally determined contributions, and for 2050 with their long-term strategies, we only add up to something like, at best, about 3 gigatons. So going from 2 to 3, and what we need to do is get to something like 5 to 10. And that's where we come up with a gap. The gap is between the 3 that we have in strategies on the right and the 5 to 10 that we'll need to meet the Paris Agreement climate targets to get to net zero by mid-century. And so the challenge now is how to close that gap, how to scale up novel CDR and to grow and maintain the conventional carbon dioxide removal. So those are big numbers. So to the median scenario, we need to get about 30 times more novel CDR than we're doing today by 2030, and more than 1,000 times by 2050. And that sounds like a lot. To some people, it sounds impossibly a lot, but it's not, because that's sort of what we've been doing with growing solar over the last 30 years. It's a little bit behind 1,300 times by 2050 if we were to apply it to CDR technologies. If we looked at something like electric vehicles, those are growing much faster than solar did, and much faster than what we would need for carbon dioxide removal, for novel carbon dioxide removal. So we have things that we've done really quickly in the past that are on par with what we need to do with carbon dioxide removal. Some of the policy implications: we say that a robust strategy for meeting the Paris temperature goal, which is reduce emissions so that we don't have temperatures above 2 degrees and make efforts to keep them below 1.5 degrees. That's the one goal. We need to limit the dependence on carbon dioxide removal through rapid and deep emission reductions, and at the same time aggressively developing and scaling up novel carbon dioxide removal. And one of the areas and kind of spin-off projects that I've been leading at Wisconsin with students and other colleagues is to talk about the formative phase. And that's really this next decade for novel carbon dioxide removal, is to think about what we do in the next 10 years really affects our ability to scale up CDR by mid-century, when we know we'll need substantial amount of it. So the amount of CDR deployment required in the second half of the century will only be feasible if we see substantial new deployment in the next 10 years, novel CDR's formative phase. So that is something that we see from other technologies that we looked at, other energy technologies, other advanced technologies, where there is this period, 10 to 15 years, where you have to de-risk the technology, you have to get the costs down, you have to create supply chains, you have to train a workforce, you have to legitimize the technology, you have to deal with reporting, get people familiar with the supporting policy. All of that is really important in the next 10 years, even if we don't really need large-scale carbon removal until mid-century. That's the formative phase. So I'll close with that and just say thanks to my co-authors around the world from the first report. We have a broader set of authors that we have engaged in the second report coming soon. We appreciate all the reviewers, project team, the lead institutions. So this was a collaboration between institutions in Austria, in Germany, in the UK, with the Follette School of Public Affairs, and multiple funders for this work. And then just a last note that on June 4th, so just soon after this video is released, we'll be launching the second edition of the State of Carbon Dioxide Removal. We brought in a bigger team. We've started to work on other issues, like how we do monitoring, reporting, and verification. And we've updated the data to see what's been happening in 2023 and into the present, to get a real sense of what's happening on the state of carbon dioxide removal. So thank you for your attention.
Thank you for watching this Badger Talks live event produced by the University of Wisconsin-Madison through UW Connect's outreach and the Office of State Relations. Follow us on Facebook and YouTube to see the library of past recorded talks. Please visit badgertalks.wisc.edu to see the schedule of upcoming talks, sign up for the Badger Talks email list, and search the roster of over 400 UW experts who are available to give talks on important issues in your Wisconsin community.